For this lesson, we're going to talk about short circuit operations. And one of the things that Java does is that it's trying to work out the code as fast as it can. And we can actually use that to our advantage in answering AP questions. So let's talk about that. So short circuit ands and ors. Short circuits. So what does short circuit mean? Well, it means that we don't actually have to entirely analyze an and or an or statement. So short circuit and an or. And think about this for just a moment. If I told you that your grade was dependent on either showing up to class or doing the assignments, would you do both? No, you'd pick one and only do that one. Conversely, if I told you that getting a good grade in this class took both being in class and doing well in your assignments, and you didn't show up to any of the classroom lectures or any of the virtual lectures here, you would already know that your grade is not going to do well, so you wouldn't bother with the assignments. Now, of course, we know that we are going to be doing the assignments and we're showing up regardless of that. But that kind of logic is what Java uses to use and or short circuiting. So let's take a look. If we know that in an if statement, so let's say if we have something that is true or, well, think about this. When your grade was either showing up to class or doing the assignments, does it matter if you do the other one? No, this one doesn't matter. Is it 2 T's? I think it's 1 T. Doesn't matter, right? As long as this side, as long as the left side is true in an or statement, both you and Java don't have to worry about what happens on the right side of the or statement. Now, if this is false, yes, we still need to look at the other side. But if this is true, we don't need to worry about what's on the other side. Same thing about ands, but it's the other way around. So if we have something here that's false, and, well, we know that and has to have both sides true. So if this side's already false, it doesn't matter what happens over here. Right? This side does not matter if this is already false. And so when we're reading through our code, as soon as we see something that evaluates to false on this side or is always false, we know we don't have to worry about that side, which can be really helpful as both a programmer and reading through the AP exam, because you don't have to worry about what's on the other side if you know this is true, say in an or question, because you will have Boolean logic on the exam. Let's see a real-world programming use of this. Let's say that we want to do division, but there is a possibility in our program that a number might be 0, and we want to avoid division by 0. So we can say if a number is greater than 0 or not equal to 0, we can do negative division. So let's say if our x does not equal 0, so if it doesn't equal 0, then it's true. Well, actually, let's do this. Let's say double equals. So if this double equals 0, then what? Well, if it double equals 0, then we don't do the other side. So then we could say y divided by x, right? And if we have y divided by x, then we could save this into some other integer. Let's say we do we could do something like this. Y divided by x, and then we could check this against something. I don't know. We could check this against, let's say, is greater than or less than or equal to 5. I don't know. Whatever. Right? If we have x equal to 0, and this is true, this side will not run, which means we protect ourselves against a divide by 0 situation. So this is an actually useful form of using x equals, or using short circuit evaluation. And you actually see this quite a bit in computer science. Okay, I'll see you guys in the next one.